Hey! An exciting new feature is coming to Angular. Signals. Signals provide a new way for our code to tell our templates and any other code that our data has changed. This improves Angular's change detection and makes our code more reactive. What do we mean by that? We'll see that in a moment. Signals are a new feature available for developer preview in Angular v16, due out in May of this year. So, what are Angular signals? Why would we use them? And how do we create, read, and change them, and react to those changes? Let's answer each of these questions and walk through a hands-on demo. We'll start with the why. Let's say we are building a feature to do some simple math. Here we set x equal to 5, y equal to 3, and z equal x plus y. So what is z? Well, if your arithmetic is anything like mine, I come out with 8. But what if we then change x to 10? Now what is z? If you said 8, you are right. The value of z is assigned when the expression is first evaluated. It does not react to changes in x or y. But one of the reasons we do Angular is because we want a reactive user interface. We want our code to react to changes. For example, when the user changes the quantity, we want the code to react and recalculate our totals. If the user deletes one of the line items, we want the totals to reflect that as well. How do we react to changes? Well, one option is to use a getter. In this example, we defined the extended price as a getter, so when the quantity changes, change detection kicks in, the template re-gets the extended price, and it gets the price times the new quantity. Alternatively, we could use an event. Here we have an event handler that is called from the template when the user changes the quantity. In that event handler, we recalculate the extended price. This works for changes in this component, but what if the totals were in a separate total component? How would it know to update its totals? That's where signals come in. Here we create the quantity as a signal. Then we create a computed signal that reacts and recalculates when the quantity signal changes. Here on the left is our original example, and on the right, similar code that uses signals. We create a signal x with a value of 5, a signal y with a value of 3, and we create a computed signal that is the sum of x and y. If we change the x signal, the z computed signal automatically reacts and recalculates, providing the new result. If we bind to z in the template, Angular's change detection kicks in, and z is updated in the template. Cool! Our components can now be more reactive. As we just saw, signals provide more reactivity. We can use signals to define our application state, basically the data in our application, and we can reference those signals in our template, so our template knows what data it depends on. When that data changes, Angular's change detection knows it needs to re-render that part of the view. This gives us finer control over change detection and can improve our application's performance. So, what is a signal? You can think of a signal as a value plus a change notification. With imperative code, when we declare a variable, that a variable is available to any code within scope. It's like putting that value on a shelf. Any code can look at that shelf and read the value, but the value doesn't react to any other variable changes. With signals, when we declare a signal, that signal value is encapsulated. It's like putting the value in a box. When the signal changes, the box glows, providing notification of the change. Any code that references the signal is notified of the change and can react appropriately. If a template reads the signal, that template is scheduled for re-rendering, and the current value of the signal is displayed. Notice the parentheses when reading the signal. This calls the signal getter to open the box, so to speak, and read the value. When you make updates to the model or data, Angular automatically applies those changes to the corresponding view. This enables a seamless and synchronized interaction between model and view, allowing for a smooth user experience. In the current versions of Angular, change detection uses Zone.js to keep the application's model and view in sync. As we see more signal features in Angular, we'll be able to create components that don't need Zone.js for change detection. Similar to how we use onPush today, we'll be able to use signals for finer control over change detection. So, signals are reactive. They provide a notification when their value changes, making it easier for our code to react to those changes. A signal always has a value. We provide an initial value when creating the signal, and we can change that value, as we'll see shortly. A signal is side effect free, meaning that reading a signal can cause no other changes nor execute any other code. So that's the why and the what. Now let's look at the syntax for how to create a signal, read a signal, set a signal, use signal methods, define a computed value, and use an effect for side effects. Then we'll open an editor and demo these features. Where can you use signals? We can use them in components to track local component state. We can add them to a directive. We can use them in a service to share state across components. We can read them in a template to display signal values. And we can use them basically anywhere else in our code. Here is the syntax for creating a signal. This creates and initializes a signal using the signal constructor function. It creates the signal of the defined type. That type can be a string, number, array, object, or any other type. Setting the type is optional, as signals can often infer their type using the default value. Like in this example, if we didn't provide the type, the signal would know it was a number. The default value is required. The signal must always have a valid value, starting with this default. Here are some examples. We create a numeric signal with a default value of 1. We create an array signal with a default array. We create a signal for a vehicle object and set its default value. And we create a signal for an array of vehicle objects. Here we set the default to an empty array. A signal created with the signal constructor function is writable. The signal value can be set to a new value, updated based on its current value, or its content can be mutated for arrays or other objects. We'll see the syntax for these operations in just a moment. We read a signal by calling its getter function. We use the signal name followed by empty parentheses. This calls the signal getter. So here we open the box, so to speak, by calling the getter and retrieve the current value of the signal. Here are some examples. We can read a signal in our code. In this example, we're reading the value of the quantity signal to display it in the console. This code runs once when the component is constructed. We can read a signal in the template. Here we use an ng4 to display each element in our quantity available signal, which is an array. And here we use binding to read the selected vehicle signal and display the name and price properties. Reading a signal opens the box to get the current value. Technically speaking, it's calling the signal's getter function, and it reads the current value of the signal. The box only contains its one current value. We replace the value of a signal using the set function. We start with the signal name, call the set function, and provide the new value. Here are some examples. In the first scenario, the user selects a quantity from a select element in the template. When the selection changes, the template calls the onQuantitySelected event handler. The code then replaces the value of the quantity signal with the value selected by the user. In this second example, we set the selected vehicle signal to a different object. Setting a signal replaces the value in the box with a new value. It notifies any consumers that the signal changed, and those consumers update when it's their turn to execute. A consumer in this context is any code that's interested in notifications when the signal changes. How does our code show it's interested in receiving notifications? If the code reads a signal, that code is notified when the signal changes. If the template reads a signal, that template is notified when the signal changes, and the template will be re-rendered. But it's important to note that a signal does not emit values, so it isn't like an observable. Here is an example. This isn't very real world, but this code could do something such as check a minimum quantity and reset to that minimum, or check against a maximum quantity and reset to that maximum. Setting a new signal replaces the signal value in the box and provides a notification. Hey, I've changed. Hey, I've changed. Hey, I've changed. But if it changes multiple times before the value is read, the consumers will only see the current or most recent value. When it's time to re-render the template, the binding reads the current value only. It knows nothing about the prior signal values. So we've looked at the set method, which replaces the signal value with a new value. Use the update method to update the value based on its current value. We provide an arrow function that passes in the current value. We can then make any changes to that value. Here we multiply it by 2. To change the content of a signal, not the signal itself, use mutate. Mutate updates the value of an array element or an object property in place. In this example, we update the vehicle's price to a new price. Each of these cases makes some change to the value in the box, notifies any consumers that the signal has changed, and those consumers update or re-render as needed. As we saw at the beginning with adding X and Y, we can create a computed signal. A computed signal recomputes when its dependent signals change. We call the computed creation function and pass in a computation function to compute the value. In that computation function, we read the values of any dependent signals. Computed creates a new signal that depends on other signals. A computed signal is read-only. It cannot be modified with set update or mutate. The computed value is recomputed when one or more of its dependent signals are changed, and the value is read. The computed value is memoized, meaning it stores the computed result. That computed value is reused next time the computed value is read. For example, say our template reads extended price in 3 places in the template. The computed value is only calculated once. It reuses that stored value for the other 2 times it's read. Lastly, we have effects. Use an effect if you want to run some code when a signal changes, and that code has side effects. Create an effect with the effect creation function. Pass it a function with the code to execute. The code is then re-executed when it's notified of a change to one of its dependent signals. Think of an effect like an observable tap operator that automatically subscribes to the signal. We can add the effect to a method, such as a constructor, or we can call it declaratively. Calling an effect should not change the value in the box. The effect is run when one or more of its dependent signals is changed, and it's this code's turn to execute. Again, it's important to note that signals don't emit values. So if the signal is changed multiple times before an effects code can be executed, the effect will only read the current value. The log will only display 42 in the console. We'll see this in action in the upcoming demo. When should we use effects? If we want to do logging, as we've just seen in those examples, or if we want to call external APIs, not including RxJS. You'll find that you won't use effects very often. Before moving on, let's take a moment and talk about signals and templates. Here is an example template. We use a signal in the ng4 and in bindings for our vehicle name, price, and total price. During template rendering, reading a signal returns the signal value. It also registers the signal as a dependency of the view. If the signal changes, the view is re-rendered. So the act of reading the signal registers that signal as a dependency of the view. The view then knows that it should re-render when any of its dependent signals change. In Angular v16, signals are available as a developer preview. They are integrated into the existing change detection model. You can also use on-push change detection if desired. Signals will mark on-push components for check, similar to how the async pipe works. Here are some suggestions for how to use signals. Continue to use event handlers for user actions. Use a signal or computed for any state or data that could change. Put shared signals in services. Continue to use observables for async operations, such as HTTP GET. There will be features to map signals to and from an observable. Now let's move on to our demo. We're going to use StackBlitz, which is an online editor. We're going to edit the package.json to v16 next so we can use these new features. We can then refresh the dependencies and we can try it out. Check out the video notes below for the link to my StackBlitz. Let's jump into a demo. I've opened StackBlitz using the link on the slides, and I'm going to click a new Angular project. Notice our dependencies are all currently Angular v15. So we're going to go to the package.json file and we're going to change them all to v16 next. At the time of this recording, it was 16.0.0-next.4. It might be newer by the time you watch this video. So I'm just going to paste that in for each one of these. Okay. Then we're going to save it, which will automatically install those dependencies. Installation complete, and it still works. Okay, so we're going to go into main, and the first thing we're going to do is create our signal. So we're going to call it quantity, and we're going to make it a number, but since we're assigning it to a value of 1, it will already know it's a number. And it's going to tell us we can't find that, so we can have it update our import. And so now it's got the import here. And if we hover over, we see that it is a settable signal of number. The next thing we want to do is display that quantity. So let's go ahead and do that in our template. So we can just change our header here. We're going to call this our shopping cart. And here we're just going to do a div and bind to our quantity. Now notice we get this weird thing displayed here on our shopping cart. Why is that? Because we're trying to display the signal. We're not displaying the value of the signal. We need to remember to open the box first in order to actually see the value. And here's our value of 1. So we can also display the value in code. So let's create a constructor just so that we have a place to write some code. And we're going to say console.log, and we're going to log out our quantity. So this.quantity, and again, we have to remember our parents to open that box and to get that value out. And we'll see here that we have a value of 1. The next thing we want to do is we want to try setting the quantity to something else. So let's go ahead and add a select. To save myself some typing, I'm just going to paste it in. And what this does is it has an ng model with our quantity, and it's calling an onQuantity selected method, which it's telling us we don't have yet. And we're binding to 2 things. So we're binding to that quantity with our ng model, and in our ng4, we're binding to an array, which is our quantity available. Now, normally we would get this from an inventory system to know how many are available, but we're going to hard code in an array. So let's start with that. We're going to do an array. We're going to call it quantity available and set it equal to a signal that is an array. And we want to set the signal to 1, 2, 3, 4, 5, 6. Quantity available now is a signal that is an array with 1 through 6 in it. So those will be the options that we have in our dropdown. The other thing we need is this onQuantity selected. And we're passing into that method the quantity. And in our code here, then, we can change that quantity. Now, it's complaining about ng model. It always complains about that because ng model is part of forms. So for that to work, we need to import forms module. And that does just like that. All right, now if you haven't seen it, this uses standalone components, which was new in v15 as a preview in v15. If you're not familiar with it, it just means that we can run without an Angular module. So if you notice here, there is no Angular module, but that has nothing to do with signals. You can completely do modules and the signals still work. Those two are two entirely separate and distinct features. But here now we have our dropdown, and notice that it did correctly bind to our signal array that we have here. And if we pick one, you'll notice that it is correctly binding to that. Now notice that our console log here did not recognize that change. That's because in the constructor, it only executes this code once. So if we actually want to see it every time it's changed, we could do that in an effect. So we can do a quantity effect. And again, you don't do these very often. We're going to just do it so that we can do some debugging here. We'd probably want to remove this when our code was actually done. And I'm just going to paste in the console log to save myself some typing. And we need to add this effect to our import. So now we can see that it says the latest quantity is 1. If I pick a different value, it now displays that the quantity is 3. Okay, so let's try something else. Let's go ahead in our code here, and we're going to try setting the quantity to 5, and we're going to set it again to 42. Just that, because that's a magic number. All right, so when we change the quantity and it calls this on quantity selected, it sets the quantity to 6, then to 5, then to 42. When this code is finished executing, then the effect is executed and it only retrieves the last value, the most recent value, which is the 42. All right, so we're going to comment that out. All right, so what else do we want to do? Let's try doing an update. So let's say we're having a 2-for-1 sale and we want to, in our constructor, when this comes up, we want to update the quantity to twice the quantity. So we can take this dot quantity and update it, and it gives us the quantity. And what we can do is take that quantity and multiply it by 2. So now you can see that it's defaulting to 2 here. And if I pick something, we can see that the last quantity now is 4. So if I pick 1, it shows that the quantity is 1. So it's always showing us the most recent value that's set into our quantity signal. Now let's try creating a signal that's an object. And I'm just going to paste mine. And it wants the definition of what a vehicle is. So I'm just going to stick it in here. Of course, this would normally be in a service, but we're just going to put our interface here for our vehicle. And our vehicle consists of an ID, which is a number, our name, which is a string, and price, which is a number. Okay, so now we're good with that. So here is our vehicle. As another example, we can also create an array of vehicles, which would be a signal of an array. Now here in this case, it has no idea what kind of array that I want here. This knew that it was a settable signal of number array, but in this case, it's any because it has no idea. So in this case, we might want to strongly type that and say that this array is going to be a vehicle array. And now it will know its correct type. And let's add a computed value up here. We're going to calculate an extended price, and that is going to be a computed. And in the computed function, we're going to say this dot selected vehicle. We need to pull that out of the box because that's a signal. So we need to do the open and closing parentheses. We're going to take its price and multiply it by our quantity. And again, that's an error because we need to call the getter and pull it out of that box. And for our computed, we need to update the import. Let's add some more information to our template then. I'm just going to paste that in, prevent you from having to watch me type it all in. But basically I added a div element for the vehicle name, one for the price, and then one for the total, which is the extended price. So that's our price times the quantity. So you can see here that it took my default signal value of 1. Down here, it updated that to be twice that, so it's 2. When that was changed, it recalculated the extended price and updated it on the template. So now if we change it to 3, we'll see that it correctly calculated our total. And if we change it to 5, it will again correctly calculate our total. So the last thing that I want to show here is mutate. We've already tried set and update. So mutate is all that's left. So here in our constructor, so we have a place to run the code. We're going to say this dot selected vehicle dot mutate because we want to update just part of what's in the selected vehicle. And it's going to give us that vehicle. And then we can do our arrow function. We're going to say we want to update the price and have it equal to the price plus price times 0.2. Kind of have an interstellar price increase there on our vehicle. So you can see that it correctly recalculated the price and the total automatically reacted and displayed the correct total there. So we don't have any code that's needing to do anything to tell the UI to update. We don't have to write behavior subjects in here. We don't have to do anything fancy. We just create signals and then we're good to roll. If you don't want to type all of this in, you can just open my StackBlitz that has all of this code in it. Check out the video notes below for the link to that StackBlitz and have fun trying out signals. Thanks for watching. If this video is useful, please like and subscribe.